In this lesson, we are going to focus on solving equations that involve a sum and difference of cubes. So let's review the formulas that we use when we factor a sum and difference of cubes. So a difference of cubes factors into a binomial times a trinomial. And when we factor, we use the acronym SOAP. And SOAP stands for same. So since this one starts with a subtraction, it's going to be a subtraction. Opposite. So the operation is going to be the opposite of subtraction, which is addition. And always positive. We're going to set up the second one as well. A binomial times a trinomial. Same means this is going to be an addition. Opposite, always positive. So now we're going to ask ourselves, what value did we cube to get an x cubed? Well, that would be x. What value did we cube to get y cubed? Obviously, that would be y. We square the first term, we square the second term, and we multiply them together. For the second one, what did we cube to get x cubed? Again, that was an x. What did we cube to get y cubed? Y. We square the first one, x squared. We square the second one, y squared, and we multiply them together. So we're going to use these formulas to solve this first equation. Now, if this exponent is a 3, that means that there are going to be 3 solutions. Now, in the past, I know many times where we were to get the variable by itself. So in intermediate, I learned that if I get the variable by itself, I would take the cube root of each side in order to get rid of that cube. Those are inverse operations. Now, the problem with that is that only gives me one solution. So then I have to think about, well, there's got to be another way to find those other 2 solutions. So instead of going directly to the solving, we are going to start by factoring. And we are going to look at the fact that this is a sum of 2 perfect cubes. So that sum of cubes factors into a binomial times a trinomial. We are going to use our acronym SOAP. Same, opposite, always positive. What did I cube to get the x cubed? X. What did I cube to get the 8? That is going to give me 2. I square the first one, I square my second one, and I times them together. Now, each one of these values I'm going to set equal to 0. That's called the zero product property. So my binomial, when I set that equal to 0, I end up with -2 as my solution. So what you're going to notice here is these actually gave me the same numerical answer. But my second part here, this trinomial, has an x squared, which means I'm going to get 2 of my solutions from the trinomial. You have a variety of different methods that you can choose to solve that trinomial. I'm going to use the quadratic formula. So I have x squared, have x squared minus 2x plus 4 equals 0. And using my quadratic formula, I have x equals -b, or the opposite of b, plus or minus the square root of b squared minus 4 times a times c all over 2a. And my a was 1. So let's keep going here. I have a negative and a negative, so that's going to give me a +2. Underneath, I have 2 squared, which is going to give me a 4, minus 4 times 1 times 4, which is going to give me a 16 all over 2. If I keep simplifying, I have 2 plus or minus -12 is my radicand underneath my root, all over 2. Well, what we notice here is solving this trinomial is giving me an imaginary solution. And I know that because I have a negative underneath the root. So I need to simplify that radical. And you've learned a couple different ways to do this. I'm going to look at that square root of negative 12. I know that's the same thing as negative 1 times 12, which is 2 times 2 times 3. The negative 1 is the same thing as an I squared. And I'm going to pull my pairs out. So I have a pair of i's that's going to come out as one I. I have a pair of 2's that are going to come out as one 2. And here is my loner. Okay, so keep going here. I've got 2 plus or minus. What did I pull out front? I pulled out a 2 and an I. And underneath now I have that loner, my 3. And that's all going to go over 2. And if I notice that, I still can go one more step by reducing, because each of these values in the numerator is divisible by 2. So if I divide all 3 of these by 2, I get 1 plus or minus I root 3. So I do have 3 solutions now. I have my first solution that I got from my binomial, that's my real solution. And I have 2 more down here, 1 plus and 1 minus. Those are my imaginary solutions. Let's look at a second example. Here I am given a difference of cubes. So let's start by factoring. I have a binomial and a trinomial. I'm going to use my acronym SOAP. S is same, O is opposite, and AP is always positive. What did I cube to get x cubed? X. What did I cube to get 343? Well, that's actually 7. I'm going to square the first term. I'm going to square my second term. And I'm going to multiply them together. So now I have a binomial and a trinomial that I need to solve. And again, I'm going to use that zero product property and set each one of these equal to 0. So for the first one, I have x minus 7 equals 0. So one of my solutions is positive 7. Second one, I'm going to use my quadratic formula. So I have x equals negative b, or the opposite of b, plus or minus the square root of b squared minus 4 times a times c, all over 2a. So this gives me negative 7 plus or minus the square root. 7 times 7 is 49 minus 4 times 1 times 49 is 196. All over 2a, and that's going to be a 1. Negative 7 plus or minus. Well, if I do 49 and I subtract 196, that actually leaves me with negative 147. It's going to go underneath my root. And if you notice that again, I have another negative. So this trinomial is always going to leave me with imaginary solutions. You will have one that is real and 2 that are imaginary. All right, now I know there I can take an I out, and you can show as much work as you want, but if there is a negative underneath, pulling an I out is the only thing that you can do. Now, 147 is divisible by 3, and when I divide it by 3, I actually get a 49. So it's 49 times 3. I'm going to double check that. Yep. So when I look at this value, square root of 49 is actually 7. So here I'm going to be able to pull a 7 out in front. And to finish this up, my last 2 solutions, negative 7 plus or minus this 7 I pulled out with the I, square root of 3, because that's my loner, all over 2. So I have my 7 from my binomial and this set of 2 from my trinomial. What I would like you to do now is pause your video and see if you can do this problem on your own. Okay, let's try this together. I have a sum of cubes, and a sum of cubes factors into a binomial times a trinomial. Use my acronym SOAP. Same, which is my plus, opposite, always positive. What did I cube to get x cubed? X. What did I cube to get 27? 3. You square the first one, you square the second one, and you times them together. Again, you can see I'm going to have 2 solutions from my trinomial and 1 solution from my binomial. Okay, zero product property. I set the binomial equal to 0, and that's going to give me a -3. I'm going to set my trinomial also equal to 0. I know this one doesn't factor, so I'm going to have to use my quadratic formula. X equals -b, or the opposite of b, plus or minus my square root, b squared, minus 4 times a times c, all over 2 times a. Again, my a here is 1 because there's no coefficient shown. So the opposite of b is going to give me a +3, plus or minus this -3 squared is going to give me a +9. Now I have -4 times 1 times 9, which is going to give me a -36. All over 2 times 1, or 2. So from there, one step further, my 9 minus 36 is going to give me a -27. Now I know I can keep reducing the 27. The negative inside is going to come out as an I. And my 27, and whether you make a factor tree or look at perfect squares, 27 is actually 9 times 3. I know 9 is a perfect square, so I'm going to pull a 3 out from here. And that's going to give me, with my final form, my 3 goes in front with my I. This loner stays inside, and it's all over 2. So again, I got 2 imaginary solutions from this trinomial and 1 real solution from this binomial. Again, I would like you to pause your video and try this problem on your own. Okay, now this problem has a difference of 2 perfect squares. So I'm going to make a binomial, or set of parentheses for my binomial, and a set of parentheses for my trinomial. Let's use our acronym SOAP. Same, opposite, always positive. What did I cube to get 64? Well, that's going to be 4, so this is going to be 4x. What did I cube to get 125? Well, that's 5, so I'm going to put that 5 in this spot. I'm going to square the 4x. Actually, going to write this out because this one's a little bit different. I'm going to square the 5. I know that's 25. And I'm going to times them together. 4x times 5. So this binomial is not going to change. 4x minus 5. This trinomial, I have to remember I have 4x times 4x, which is 16x squared. My 4x times 5 is going to give me 20x, and I have my 25. Now I have 1 solution that's coming from this binomial and 2 solutions that are coming from this trinomial. And again, I know these are going to give me imaginary solutions. So Zero product property says we're going to set each one of these equal to 0. So that's going to give me 4x equals 5. If I divide both sides by 4, it gives me 5/4 as my real solution. All right, these numbers are pretty big, but I have x equals the opposite of b. Here's my b. Plus or minus the square root of my b squared minus 4 times my a, which is 16, c, which is 25, all over 2a. And again, my a was 16. So negative 20 is going to stay. I don't know if you know what 20 times 20 is, but 20 squared is going to give me 400. I have a negative and a positive, so that's going to stay negative. And 4 times 16 times 25, I needed my calculator for that one, is going to give me 1,600. All over 2 times 16, which is 32. All right, we have a couple more steps to simplify. Negative 20 plus or minus. If I have 400 and I subtract 1,600, that's going to give me a negative 1,200. All over that 32. I know this negative underneath the root is going to come out as an I, but I have to break up that 1,200. Now, I know that if I divide that by 400, it's going to give me a 3. So just going back to the math that we had before, when I had 20 and squared it, I got 400. So I know 400 is a perfect square. So I have the I out front. I have my 1,200, which now is 400 times 3. Again, if you'd rather make a factor tree, you can. That's a little bit too much for me. But again, I know that this 400 is a perfect square, 20 times 20. So I'm going to pull that 20 in front. Negative 20 plus or minus 20i. This loner, the 3 stays inside, all over 32. So I'm hoping I'm finished there, but I always have to go back and check to see if I can reduce my fraction. Now, I see an even number here in each of those spots, which means I know I can take a 2 out. But if I think about it, I actually can divide all of those by 4. So that means my final 2 answers, my imaginary answers, 20 divided by 4 is going to be a negative 5, plus or minus. This 20 by 4 as well is going to be a 5i root 3. And the 32 divided by 4 is going to be 8. So I have my real solution here for my binomial. And I have my 2 imaginary solutions here for my trinomial.